So now we are going to discuss about artificial neural networks. Why it is called the artificial neural networks? Because these networks are developed artificially by taking the inspiration or by mimicking the functionality of the neurons in a human brain. How neurons are connected, how neurons are activated, how neurons are works to take some action based on some inputs. So how we can take an action. So that is happening in the human brain based on the neurons connection. Based on the neurons connection. So based on the neurons connection. So same as by taking the inspiration from the human brain neurons and by taking the inspiration from the functionality and by mimicking the human brain, we develop the neural networks artificially and we are implemented in a computing machine using some programming language. That's why these neural networks are called as the artificial neural networks. So artificial neural networks are the networks which are developed by mimicking or by taking inspiration from the functionality, from the construction of a human brain neurons. And these networks are constructed on a computer using any of the programming language. It may be a MATLAB or it may be a Python. And we will use that model which was developed in the computer. That model will act as our human brain. So how we are taking the decisions, like that your machine also take a decision. See, initially when we join in a school as a small kid, a nursery kid, we don't have any information in our human brain, like some random information. But once we joined in a school, then teachers will tell. So they will write a word A and they will tell that this is A. Then what we will do, we will see that figure, we will see that letter, and we will practice multiple times. Then our neurons will be excited. Right? So from later onwards, whenever we see the letter A, then we can easily remember. So this is the letter A. We can easily remember. We can easily recollect. Why? That information is stored in our human brain based on our training process. In the same way, we will develop a neural network model for a temperature prediction or load prediction or humidity prediction or stock price prediction, whatever it may be, based on some inputs. We will train our model based on those inputs. Once training was completed, though that model is able to tell what will be the temperature for the next day, what will be the load in the next day, based on the few input features, like what we did. When we learn, then we say that there is one slant line and one slant line, one cross line, this is the A. From next onwards, when we say the type of letter, one slant line, one cross line, then we can easily recollect this is the A. Why we are able to recollect? Because our neurons are trained accordingly based on the data. One slant line, one cross line. Like that, our neurons are already trained. So whenever we see that type of figure, we can easily tell that this is the A. In the same way, we have to build some artificial neural network on a computer model, on a computer, and we will train that model based on some data. That may be a temperature data for a temperature prediction, that may be a load data for the load prediction, or that may be some other stock price data for the stock price prediction. Okay, so based on that data, now your neural model is able to predict. If you give some new data, like a previous temperature data, it is able to predict the next day temperature data. If you give the previous load data, it will give the next day load data. Why it will give? It's already trained in the previous way. Hope you understand. So this is the theory concept. I don't want to much focus on it, but we are trying to going in depth slowly. But simply what I mean to tell you is, so neural networks are artificial neural networks are the neural networks which was developed artificially on a computer using any of the programming language in such a way that your neural network model will mimic your human brain process. How our human brain function, how our human brain will perform, in the same way your neural network model also will perform. Right? This is some theory perspective. Now we will discuss how we will construct the neural network model, how it will work, and how it will train, how model parameters will update, how it will predict, and everything we were going to discuss in today's class. Fine. So no much theory discussion. So I'm trying to go with some mathematics and later with the implementation. Fine. Let's share my screen. Done. Fine. Let's consider where is my pen? Right. So now we are trying to build neural networks from the very, very simple to complex model. Slowly we will dive into the complexity. Not directly we are going and we are not entering into the complex model. Slowly we are entering into the complex model. Okay, fine. So let's assume I want to predict, I want to predict some input y. I want to predict some output y. I'm trying to predict some output y. The y will be maybe a temperature, maybe a load, maybe a humidity, maybe a stock price, maybe a gold price, or maybe some cancer detection. It may be some COVID detection, whatever it may be. That is the y output, what we are going to predict. So this y is called as the output variable, or also called as the target variable. This is called as the output variable or target variable. Output variable or target variable. I hope you understand, right? So this is what we are trying to predict. Okay. So I want to predict, I am trying to predict some variable y, target variable y or output variable y based on some inputs. Let's assume x1, x2, and x3. Let's assume x1, x2, and x3. So, for example, I want to tell one thing. Let's assume I am trying to predict whether the person has a COVID or not. So my output will be COVID or not. For example, I'm saying COVID or not. That's the output variable. I'm trying to predict whether the person has a COVID or not, whether it is a COVID positive or COVID negative. Based on some features, maybe like fever, maybe like O2, maybe like cold. So these are called as input features, and this is called as the target variable or the output variable, right? So here x1, x2, and x3, nothing but the fever, O2, cold are called as the input features. Y is called as the output variable. Y is called as the output variable. All right. Now you collect some data. You may collect some data like maybe collect some data like maybe he has a fever like 1 or 2, he has a O2 level like 80, he has a cold S, then it may be a COVID positive. It will be COVID positive. He may have a fever like 98 and he has a O2 value 100 and the cold is no cold, then he don't have a cold. Like that we can collect the data. Like that we can collect a few samples of data to train your neural network model, right? If you want to train our human brain, if you want to train our child on an English language, we are giving the some data. The data contains the alphabets. So A, B, C, D, such type of data we are given to the our children's, and he will practice. The neurons will be excited. Later, once he saw that same letter A, then he is able to recollect it is the A, it is a B, it is a Z, like that easily recollect. That means if you want to make our human brain to learn something, we have to feed some data. In the same way, if you want to train your neural network model, artificial neural network model for any specific problem, then you have to give the data related to that problem. If you want to build a neural network model for the COVID diagnosis, you have to give the COVID related data. If you want to build the ANN model for the temperature prediction, you have to give the data related to the temperature. If you want to train you want to build the ANN model for the humidity prediction, you have to give the data related to the humidity. If you want to find the household price in a Warangal region, you want to build a neural network model to find the house prices in a Warangal region, then you have to give the data related to the house prices in the in Warangal. Okay. So like that, we have to give the data. We have to prepare a data initially. So let's assume I have a data like this. So I have the 3 input features x1, x2, and x3, and one output variable y. One output variable y. Okay. And small thing here, power was there is a power Hope it is audible now. So sorry, there is a power failure here. That's why I was disconnected in the middle. Now hope you are fine and you are able to hear me. So first step is, if you want to build some neural network model, first of all, you need to identify your features. You need to identify your features. What are the input features you are considered, like fever, O2, and cold, and what variable you are going to predict. That is called the target variable that you are going to identify. Okay. For example, I hope everyone is online. Let's assume first, you have to understand the problem statement. Whenever you want to apply the neural networks for any type of prediction, first you try to understand your problem. Let's take an example. Like, I'm trying to predict the electric load on a substation at a particular day and a particular time based on the last 3 hours load data. Let's assume last 3 hours load data. So that is your problem statement. Let's assume. Then you need to understand the problem statement carefully. That means, so what we are going to predict? Yes, we are going to predict the load on a substation at a particular time and particular day. Based on what? That means, what are the input features? What are the input features? Last 3 hours load data. I'm trying to predict the load at a particular time based on the last 3 hours load data. So you have to understand your problem statement carefully, and you have to identify what are the input and what are the output features. In current state, so I want to predict the load L of t, that means load at a particular time, I want to predict. So it is called as the target variable. It is called as the target variable. Okay, it's called as a target variable. Based on what? Based on the last 3 hours load data. That means L of t minus 4, that means 1 hour before load, and L of t minus 2, 2 hours before load, L of t minus 3, 3 hours before load. So these three are called as the input features. So these three are called as the input features. These three are called as the input features. I hope you understand. Huh? So first you need to understand the problem statement very carefully. That's the first step. Once you clearly understand the problem statement, you need to identify what are the input features and what is the output feature. That's the second step. Once you're clear with your input features and your target variable, then you have to collect the data. Next step is, you need to collect the data because you require data to train your neural network model. You require data to train your neural network model, right? Hope you understand, right, what I mean to say. So you need data to train your model. So collect the data. So first understand the problem, identify the features. What are the input features? What is the target variable? Later collect the data. Once the data is ready, now move to the architecture of your neural network model. You have to build some architecture of your neural network model. So clearly understand, I'm trying to go from the very simple model and later we are trying to improvise. Okay, fine. Now there is a neural network model. I don't know what is the architecture inside. This is called as my ANN model. First ANN model. Okay. Now for this ANN model, what the purpose of this ANN model? I am trying to predict some variable. So I am trying to predict some variable. That variable is called as the YP. YP nothing but the predicted value. So Y is nothing but the target variable, that is the actual value. YP is nothing but the predicted variable, and Y is called as the actual value. I am trying to predict the Y. I am trying to expecting Y, but YP is my predicted value. So our training process main goal will be, I am trying to predict the Y value as close as possible to your actual value. If the temperature value is 40 degrees centigrade, I have to close to your 40, like a 39.8 or 39, like that, not like a 27. So whatever model is predicting, that should be close to your actual values. Okay. So Y is called as the actual value coming from your data set. YP is called as the predicted value by your neural network model. Hope you understand, right? Now, okay, fine. This ANN model will give the prediction YP based on what? Based on what? So those are called as the X1. That is the one input feature. This is another is the X2. That is the another input feature. And this is called as the X3. That is the another input feature. That is called the X3. That is the another input feature. Right? Hope you understand. So there are the three input features, x1, x2, and x3, and yp is the predicted variable value. Yp is the predicted value, right? So I'm trying our model, my machine learning ANN model is predicting some value. Target variable is predicting based on my input features x1, x2, and x3. So x1, x2, x3 are called as the input features, and y is called as the target variable, and where yp is called as the predicted output. It is the predicted output, this is the target output, this is the predicted output, these are called the input features. So this is your ANN model. Now, how your ANN model looks like inside? How ANN model looks like inside? Okay. Now I'm trying to open it. What is inside? So inside is every input is going to the one neuron in your neural network model. This is representation of the neuron. So every input is going to the one neuron. Every input is going to the one neuron. So this layer is called as, so I will use color. So this layer is called as input layer. This layer is called as the input layer because the input values are connected to these neurons. So this is called as the input layer. Fine. Now this the another layer is called as the, I'm taking a simple model. Slowly I will increase the complexity. Don't worry. So next layer is called as the output layer. So in the output layer, so in the input layer, the number of neurons in the input layer is depending upon the number of input features. Here the input features are x1, x2, and x3. Three input features so that I have the three neurons. Okay. Now coming to the output value, in the output side, how many target variables are there? I have the only one target variable. So number of neurons in the output layer is equal to only one. Why? Because we have the only one variable we are going to predict. There is only one target variable, so that there is only one neuron in the output layer. Right? So now all these neurons are interconnected. All these neurons are interconnected, fully interconnected. So all the neurons are fully interconnected. Fully interconnected, right? And every connection has some weight. Every connection has one weight. So that weight initially, when a newborn child in his human brain have multiple neurons, every neuron is interconnected, but there is no information inside, only some random data in his human brain. You don't have anything. Like that, in your neural network model also, initially you have the random data like W11, W12, sorry, W11, W21, and W31. These are called as the weights between the input neuron and the output neuron. Okay. This is a random. Random, we have to give some values like a newborn child has a random data in his human brain. Like that, you can give some random information, random weights to your neural network model, W11, W21, W31. This is a random weight. Like that, your input neurons and output neurons are connected. And from this output neuron, you will get the predicted output. From this output neuron, you will get the predicted output. So like that, inside your ANN model, you are able to see these things. Up to now, I think you are clear. Now, I hope everyone is following. If you are responding, that would be very interesting for me. I'm giving them a small case study. Let's assume I'm trying to forecast the electrical load on a substation at a particular day and a particular time. That means I'm trying to predict the load on a substation today at 2 o'clock. Now it's 1:59. What will be the load at the 2 o'clock? Let's assume. I'm trying to predict that load based on the last 3 hours load data. Last 3 hours load data means what will be the load at 1 o'clock, 2 o'clock, 1 o'clock, 12 o'clock, and 11 o'clock. At the same time, I'm trying to predict the load based on the last 3 hours load data also. That means yesterday 2 o'clock, day before yesterday 2 o'clock, and before that 2 o'clock. So this is my strategy I want to follow to predict the load. I'm not saying that it's a good strategy. Just I'm giving some case study for you. Some case study for you. Now my question is, if this is my problem statement, tell me number of neurons in the input layer and number of neurons in the output layer. Anyone, please. How many number of neurons will be in the input layer and how many number of neurons will be in the output layer? If my problem statement you are able to understand, you can use chart box also. how many number of neurons will be in the input layer and how many number of neurons will be in the output layer?
Three neurons in the input layer, sir.
Okay. Number of neurons in the output layer? One. That number of neurons in the output layer is right, sir. This is only one because I am trying to predict the load at 2 o'clock at a particular time. That's one. Perfect. But you can understand again, sir, what my problem statement here is. I'm trying to predict the load at a particular day and a particular time based on the last 3 hours load data, at the same time last 3 days load data. That means I'm trying to forecast the load 2 o'clock today based on the load available as last 3 hours. That means 1 o'clock, 12 o'clock, 11 o'clock, and last 3 days. That means what will be the load yesterday, 2 o'clock, what will be the load at day before yesterday, 2 o'clock, what will be the load at 2 o'clock before that day. This is my strategy I want to follow to forecast the load. I think now it's clear with the problem statement. Now tell me how many number of neurons in the input layer. Fine. So I'm trying to predict the load at a particular time based on the last 3 hours load data. That means L of t minus 1, L of t minus 2, L of t minus 3. Those are the 3 other input features. At the same time, last 3 days load data also. So what will be the load at 1 day before, what will be the load at 2 days before, and what will be the load at 3 days before. So what are the total number of input features? 1, 2, 3, 4, 5, and 6. So total 6 input features. So the number of neurons will be 6 in the input layer of a neural network model. That based on the how we are approaching, how we are preparing the data. Based on that one, the number of neurons will be changes. So the number of neurons in the input layer is depending upon the number of input features, and the number of neurons in the output layer is depending upon the number of output variables that we are going to understand. Okay. Now architecture is ready. That's fine. Now we have the architecture. That architecture is readily available, and we are initializing the random weights W11, W21, and W31. Fine. So what next? How we will approach? How we will train this model to predict YP based on the inputs X1, X2, and X3. Okay. How we will work on it? We will discuss now. Now, in case of the training, what we will do is try to give your samples. That means you have to give the X1 value, you have to give the X2 value, you have to give the X3 value to your neural network model. So you will get some values X1, X2, X3 we are feeding from the data set. Okay. Now, step 1 is, you can see, step 1, clearly observe how the model will learn based on the available data. Okay. So read your data first. Read data. What are the data you have? X1, X2, and X3, and corresponding Y value. You have to read the data. So if X1 this one, X2 this one, X3 this one, this is the Y value. So corresponding Y value you have to give. So this is the data you have to feed. Now, once these X1, X2, X3 values given to the 3 input neurons, and you have the weights, right? So what are the weights? You have to randomly initialize the weights. Randomly initialize weights. Randomly initialize weights. Okay, so you have to randomly initialize the weights. That means you have to get the values W11, W21, and W31. That's also you have to complete. So once you have this data, so next step is step 2. That is, you have to calculate the net input to your output neuron. What is the net input to your output neuron? Net input to the output neuron is your X1 into W11, your X2 into W21, your X3 into W31. All are connected. All are connected. So net output, net input to your output neuron. Net input to your output neuron, that's equal to, net input to your output neuron is equal to how much? W11 into X1 plus W21 into X2 plus W31 into X3. Right? So because I am using the linear activation function, whatever the input is coming to your output neuron, same will be coming as an output value of your output neuron. So it is equal to your YP. This is the YP. So hope you understand. Okay. So simply I can write your predicted output equal to your weight matrix. This is my weight matrix. Your weight matrix multiplied by your input matrix. This is my input matrix. So my input matrix is x equal to x1, x2, and x3. I want to multiply my weight matrix and my input matrix. My weight matrix and the input. That's it, right? W11 into x1, W21 into x2, W31 into x3. Otherwise, we can rewrite this expression. This can be written as W11, W21, W31 and multiplied by x1, x2 and x3. So this is called as my weight matrix multiplied by my input matrix. So that is your predicted value. That is your predicted value. So this is what your model is predicting. Next, step 3 is you have to calculate error. You have to calculate the error. How we calculate the error? Yesterday we discussed the half mean square error. Yesterday we discussed about the half mean square error, right? So how we calculate the error? That is the 1 by 2 into error, nothing but the difference between the your target value, actual value, and the predicted value. That means we can write y minus yp whole square. Okay. So this further can be written as 1 by 2 into y minus yp can be written as w into x whole square because yp equal to w into x whole square. This is my error. Okay. Now tell me, what is our goal during the training process? What is our goal during the training process? Yesterday we discussed it. Anyone? So up to now, fine. Only we are giving the input data, we are multiplying the weights, and we are getting the target predicted output, and the predicted output is compared with the actual output, and we are calculating the error. Up to here, it's fine. Now I want to train the model. So what is the main goal of your training process for any model in case of ANN also? What is the goal? What is the motive? Why we are training the model? What we are expecting? Anyone, please? Yesterday we discussed actually. Anyone, please? So what is the goal or motto or what is the need of training? What we are expecting based on the training? Anyone, please? Anyone? So our goal is we are trying to update our model parameters. What are the model parameters? What are the model parameters? W11, W21, W31. That's called W. So W is our model parameter. That means we are trying to update our model parameter. So carefully listen. If you are listening the class for some times and you are deviating to some other work and coming back to the class, then it's not understandable for you. Okay. So my goal is I'm trying to update the model parameters or the weights of a neural network model W11, W21, W31, W11, W21, and W31. Okay, such a way that my predicted value yp is close to my actual output y. My predicted value yp is close to my actual output y. Actual output y. Okay. So that error will be minimized. Error will be minimized. So my motto of training process is I'm trying to minimize this error by getting the predicted value more close to the input value by updating the model parameters of the weights W. That's my goal. Now tell me, if you want to minimize this error function, what will be our steps? We want to use the gradient descent algorithm. So as per the gradient descent algorithm, what is our first step? We are trying to minimize this error function. If you want to minimize the error function, if you want to apply the gradient descent algorithm and want to minimize the error function for optimization. So what is the first step? At least that also you can respond. If you want to apply the gradient descent algorithm, already weights are randomly initialized in the step 1. So what will be the next step we have to do if you want to use the gradient descent algorithm? If you want to apply the gradient descent algorithm, what we are going to do in the step 4? Anyone, please? Please respond. Otherwise, it's like I'm teaching the class to a wall. So no use, right? Anyone, please? Anyone, please respond. What may be the next step? Okay. For easy of understanding, that's I'm taking the y is called as my desired output, and the yp is called as the output what I'm getting. Just for easy of understanding, that's it. So that's equal to 1 by 2 into d minus o whole square. 1 by 2 into d minus o whole square. Okay, this is my error function. So my O value, nothing but the YP value, is depending upon the my weights W. It's depending upon the my weights W. So what we can do now? So we have to calculate the Y means the W nothing but the W11, W21 and W31. W11, W21 and W31. So what we are going to do, we are trying to calculate the delta W. That nothing but the change in weight W11, change in weight W21, change in weight W31. That's equal to, yesterday we know about this one, calculation of the step length. That's equal to minus eta into gradient of a error function, gradient of a function. So dou E by dou W. So simply written as minus eta dou E by dou W11, dou E by dou W21, dou E by dou W31. That's what we are trying to do. So what will be the output here? So this is equal to minus eta. So tell me, what is the dou E by dou W? So what is the dou E by dou W? So how we can write? So we have to differentiate this one with respect to W. So W11 means, so you can see, so this can be written as 1 by 2 into Y is nothing but the D minus Wx is nothing but the Yp, nothing but the O whole square. So can be written as dou E by dou W. W will be exist in the O. In the output, you have the W, right? How we will get? So first 2 comes forward. So 2 will be cancelled. Then you have the Y minus W into X, Y minus W into X. And again, we are trying to differentiate. Again, we are trying to differentiate. See, just it coming forward. That's it. Right? Dou E by dou W can be written as, dou E by dou W can be written as, you can write dou E by dou O and you can write dou O by dou W. So dou E by dou O is nothing but the, just to come forward. And this is the negative sign that will come forward, the negative sign. Right? And again, dou O by dou W, O equal to Wx. Dou O by dou W equal to into X. Right? That's it. So now we can write this expression. How we can write? This is a minus Y minus W into X. So W into X is nothing but the O. Or Y is nothing but the D, right? Y is nothing but the D. Y is nothing but the D. So D minus W and X equal to O multiplied by your input value X. Your input value X. That means what you have minus eta, dou E by dou W1 is nothing but the minus D minus O W11. What is the input to the W11? What is the input to the W11? X1. So it is the X1. Right? So again you have the dou E by dou W21. What you have? Dou E by dou W21, that's equal to minus D minus O into X2 minus D minus O into X3. You can simply write minus and minus becomes plus eta into d minus o into x1 and x2 and x3, that's equal to delta W. So this is how we can calculate the change in weights. During the training process, the weights will be updated based on this formula. So this is called as the withdrawal of learning. This is called as withdrawal of learning. This is called as withdrawal of learning. In the withdrawal of learning, we consider the linear activation function. In the withdrawal of learning, we consider the linear activation function, and the withdrawal of learning will help you to update the model parameters based on the formula, that is the delta W equal to eta into d minus O into x. X is nothing but your inputs. X is nothing but your inputs. So that you have to remember. That's very, very important. Okay. If you are not following, if you are not responding, it's a very, very simple thing I am started. At this stage, you are not responding means when you go in depth of the complex thing, I'm not expecting anything from you. It is very simple. You are not responding means no one is listening. Then what is the motto for me to deliver the session? You can understand. Fine. So next step number 5. Next is the step number 5. So what the after calculating the step length in a gradient descent algorithm, what is the next step? Updating the variables. So here also we are trying to update the weights, or we are updating the model parameters. Weights or model parameters all are same. Weights or model parameters all are same. So we update. So W equal to weight matrix W equal to W plus delta W. It simply can be written as W11, W21, W31. That's equal to old W11, W21, W31 plus eta into d minus O, because delta W expression is available here. Eta minus d minus O into x value, nothing but x1, x2 and x3. This is the formula you need to use to update your model parameters or update your weights of a artificial neural network model for your predictions. Okay. Now, so once your model parameters updated, what will be the next step? What will be the next step? What is the next step in the gradient descent algorithm after updating the model, after updating the variables x equal to x plus delta 6? What will be the next step? That is the step number 6. Step number 6, that is called as update your iterations. Iter equal to iter plus 1. Iter equal to iter plus 1. We are going to update the iterations. Okay. So next step is step number 7. So what is the next step? If your current iteration value is greater than epochs or not. If it is a true, that means epochs means maximum number of iterations. If you are reaching the maximum number of iterations, then you going to stop your algorithm. If it is not, you are not reaching the maximum of iterations, false, then again go back to calculation of your output of your neural network model and calculate the error and calculate the change in length and update your weights. So these 4 steps should be repeated. So we are going to the step number 2 back. So this process again, go to the step number 2, calculate the predicted output based on the updated weights and calculate the error based on the updated weights and calculate the change in weights based on the error value, and later again update the weights. This process, these 4 steps will be repeated until you are reaching your maximum number of epochs. This is the algorithm to update the artificial neural network model using the withdrawal of learning. So this is the theory part that I explained till now. I am trying to show the implementation also. I'm trying to implement the withdrawal of learning based training process of a neural network model with a small sample data. Right. So actually, my intention is I'm trying to predict the variable X based on my input features A, B, and C. Whatever may be, A is the one input feature, B is the another input feature, C is the another input feature. So these are the input features and these are the values. Based on these input features, I am trying to predict a variable Y. So X is called as my target variable. A, B, and C are called as my input variables. A, B, and C are called as my input variables. Okay. Hope you understand that. This is the problem. So I'm trying to build one artificial neural network model to predict the variable X based on the input features or input variables A, B, and C. Data is readily available. Okay. Now, how we will build the neural network model, that we will discuss. Okay. Now, go to this part. First, this data is available in my Google Drive. Actually, this data is available in my Google Drive. 1 minute. This data is available in my Google Drive. I will show that part also. So where this data is available in my drive, there is the NNL data folder. In that folder, I have the sample data 00. This complete data is available in the Excel format. You can see in my drive NNDL data. So in NNDL data, I have the sample 00. Yeah, this one sample data 00 is available. Now I want to load this data into the Python environment. So for that one, first I am trying to mount my Google Drive into the Colab. Just I'm trying to mount my Google Drive. I want to create a link between my Google Colab notebook with my Google Drive so that I can access the content available in my Google Drive. To access the content available in my Google Drive, to create a connection from my Google Colab to my Google Drive, simply use these 2 lines of code from google.colab import to drive.mount. You have to use this one. So run this one. Run it. So connect to Google Drive. Just my account details. Continue. Continue. As of now, nothing is available. Once this code is executed successfully, then you are able to see my drive content here, my Google Drive content available here. As of now, nothing is available, right? Now it's executed. Just I'm trying to refresh it. Now my Google Drive content is available. Just click here in my drive in NNDL data. So there is a folder called, there is a file called sample data 00. So I want to load this data because this Excel file contains this data where X trying to predict based on the inputs A, B, and C. So to get this data, to read the data, to read this Excel data from this Google Drive, so you have to use the, you have to import these 2 libraries, NumPy library and the Pandas library, which are available for the data manipulation and the array operations. Now I want to read the data available in this Excel sheet. For that one, you can use pd pandas dot read Excel, and you have to copy the path where your Excel file is available. Where my Excel file is available, this is my Excel file, right? You have the 3 dots. Just click here, copy path, and paste that path in between the quotes. Just paste this path between the quotes. Just it. Now you can run this piece of cell. Then what happened is whatever data is available in this path, in this Excel, that will be read and that will be stored in a variable called data. So you can see that the data content, whatever the content is available in the data, that will be visible here. Same content, you can see 0.1, 0.2, 0.3, 2.3, 0.1, 0.2, 0.3, and 2.3. Right? So if you want to see the complete data, remove that head and you can see the complete data as well. All complete data that is available here, all you can see here. Last one is the 0.4, 0.5, 0.2, 4.3, 0.4, 0.5, 0.1, 0.3. So this data is already available in this location. Just I read the data using the pd.read Excel command and the data is stored in this data variable. So now data is available in the Python framework. So what next? So actually I want to tell one thing. During the training process, when we are making students to learn something, when we are trying to we are trying to learn, we are trying to make students to learn some concept, some topic, some subject, some syllabus, then what we will follow? For every unit, I will prepare around 10 to 15 questions. Let us say I prepared 15 questions for every unit. But in the classroom, during the training process, I will not explain all the 15 questions. Out of 15, only 10 questions or 12 questions I will instruct him, I will dictate him in the classroom. And remaining 3 questions I will keep aside to test him during the examination. I don't want to test my student based on the content what I discussed in the classroom. Based on the content discussed in the classroom, he wants to generalize. Later during the testing process, I will give you some new questions. I will check whether the concept that you learned during the training, classroom training, whether he is able to apply that concept, that knowledge to solve the new problems that are coming in the examination. So what I mean to tell is, whatever the data I have to teach to students to learn, I don't want to give the complete data during the training process in the classroom. I will give the few data, few information to the student in the training process in the classroom, and I kept a small amount of data to test the candidate knowledge after training. That means I am separating the data for the training purpose and also for the testing purpose. That is called as splitting. So similarly, in the artificial neural network model also, we need to split the data for the training purpose and also for the testing purpose. To split the data for the training and testing purpose, there is one method called train underscore test underscore split method that is available in the Python. Okay. So that method you have to call from sklearn.model selection. You can import train underscore test underscore split method. Now, this method will help you to split the data for the training and also for the testing. For the training and for the testing, that will be helps. How will that will fit? So data underscore train, that the variable holds the training data. Data underscore test, that will hold the test data. Okay. So that's equal to train underscore test underscore split. That's equal to train underscore test underscore split method. And you have to pass your original data, the data which you are going to split. So splitting means we have the 11 samples, right? Out of 11 samples, few samples are going to the training purpose and remaining samples are going for the testing purpose. So you have to use the train underscore test underscore split method and you have to pass the variable which holds your original data, that is the data. And here you have to give the test size. What is the test size? Test size means how many percentage of samples you want to use for the testing purpose. You want to use for the testing purpose. Here, what I am keeping 0.05 means 5% of data I want to use for the testing purpose. Out of 11, so 5% means around one sample will be used for the testing and remaining samples will be used for the training. So out of 11, one sample, that may be a 6 sample, that may be 8 sample, that may be a 3rd sample, whatever it may be, randomly pick. That sample is for the testing purpose we will kept aside and remaining samples will be used for the training purpose. The remaining samples will be used for the training purpose. Okay. Now, so Q1 equal to, it's fine. Okay. So by these two lines are sufficient to split the data for the training and for the testing. Then these two remaining lines are I'm using additionally for small processing. You can see Q1 equal to LEN means length of your data underscore train. What it will give? Number of samples available in the training data that will be extracted and that will be stored in a Q1. Q1 represents the number of samples in the training data. Similarly, Q2 will represent number of samples in a test data. And I want to convert these training data and test data into a NumPy array. NumPy array I am trying to convert. Just simply run this piece of code. So data split was completed. So after data is completed, now you can see our algorithm. Discuss this algorithm, right? So our first step is completed. So we are reading the data for the training purpose. The data is available under the data underscore train. And for the testing purpose, the data is available under the data underscore test. Many things are there. So if you ask some questions, if you respond, that will create some interest for me. Right. Data train and data test. So that's completed here. Next one is randomly initialize the weights. So you can see this part, randomly initialize the weights. How many weights you have to initialize here? W11, W21, W31. We want to initialize the W11, W21 and W31. That means 3 rows. That means, so this will be like a, sorry, W, what happened? So I want to get W11, W21, second row, and W31. I want to create this matrix, weight matrix randomly. That means 3 rows and 1 column weight matrix. I want to create randomly. Why only 3 rows, 1 column? Because our architecture will be like that. So W11, W21, W31. That's why W11, W21, W31. Only 3 rows and 1 column. Okay, but these weights should be initialized randomly. These weights should be initialized randomly. So how this will be initialized randomly? So you get weights initialization, random initialization. So weights, that is the weight matrix, W matrix equal to NP, because NumPy array, we are alias name is NP, NP dot, yesterday we discussed this one, NP dot random dot uniform, NP dot random dot uniform. I want to randomly generate the weights in the range of -10 to +10. You can choose any range, -100 to +100, -1000 to +1000, -900 to -900 to +1000. That is your choice. You can choose any range. Okay. And what is the shape of our weight matrix? 3 rows and 1 column. So 3 rows and 1 column size you have to decide. Now it will give the random weight matrix. You can see what are the weights. So this is the one weight W11, this is the W21, and this is the W31. That is randomly generated between the -10 to +10. That randomly generated values. So random weights are completed, right? So what will be the next step? Now we are going to the training of the machine learning model. Training of the machine learning model. So in the training of the machine learning model, what we will do? Based on the gradient descent algorithm, what we will do? So if you want to update the model parameter for every iteration, if you want to update the model parameter in every iteration, how we update the model parameter in every iteration? W equal to W plus delta W. If you want to calculate the delta W, what you require? Eta, that is called a learning rate. D means desired output. That means your actual output that is available in the data set, last column, X. And 0 means what your model is predicting. That is the O. What is your model predicting? That is the O. And whatever this x1, x2, x3, that is nothing but your input features. X1, x2, x3 is nothing but your input features. O is called as your model prediction, and D is called as the last column of your data set after x1, x2. That means after 3 input features, the last column is your desired output D, and eta is nothing but your learning rate. That means if you want to calculate the delta W, you require eta value, you require the actual output, you require the predict output, you require the input features. And you have to multiply all 3 to get the delta W. And once you got the delta W, then simply update your weights. W equal to W plus delta W. W equal to W plus delta W you have to complete. So first you have to calculate the delta W. So how we calculate the delta W? But if you want to calculate the delta W, you require O. So how we calculate the O value? So O equal to W11 into X1 plus W21 into X2 plus W31 into X3. That means that nothing but the weight matrix into input matrix, right? O equal to YP and YP equal to W into X. You can see here. So output equal to W into X, weight matrix into input matrix, right? So that's what I'm saying here. So there is a two loops actually. So actually what we have to do is once again, I will draw this flow chart, then you can easily understand. So start your algorithm and read data. So your data is, what is the data for us here? In our case, what are the inputs? A, B, C, and X is the output, right? So read data. So data contains A, B, C inputs and corresponding output X. And also you need to read the randomly initialize weights. So randomly initialize weights means, so you have to initialize weights W11, W21 and W31. That is called as the weight matrix. W you have to randomly initialize. Sorry. So you have to initialize the weights randomly. You have to initialize the weights randomly. W. You have to initialize. That's called W11, W21, and W31. You have to randomly initialize. Later, you have to initialize the learning rate value like 0.01 or 0.1. You have to initialize. And what next? You have to tell how many number of epochs, how many number of iterations you want to run this training algorithm. Okay. So this is what you have to do. Let's assume this is the training data. Okay. All A, B, C, X values are training data. We are using the training data to train the model. We are using the training data to update the model parameters. We will use the training data to update the weight parameters of a neural network model. All right. So please clearly understand that's why I took the more time to concentrate here. If you not understand, you don't know what happened behind your neural network models. So after that, what we will do? So actually in your training data, you have the multiple samples. We have the 11 samples. Out of 11 samples, one sample go to the testing and you have the 10 more samples. You have to take the sample 1. You have to take the sample 2. You have to take the sample 3. Like that up to 10 samples you have to take, update the weights. So what you have to take? Now you have to take the sample, first sample you have to take. So after taking the sample contains the A, B, C values, input values. Only you have to take the input values corresponding output value for every sample. For every sample, you have A, B, C, and X. This is the data, right? Your sample 1 has some values. Sample 2 has some values. Sample 3 has some values. So you have to take the every value. You have to take the every value. Take the first sample, take the next sample, take the next sample, like that you have to do. First take the first sample. So now what you have to do after taking the first sample, calculate the predicted output by the neural network model. How we calculate the predicted output? Already we have the W, weights. And already we are taking the S1, first sample X value, that is input values you have to take. You have to take the input values. That means W into your input values, A, B, C. These are the input values you have to multiply. That's what, right? We are getting here. You can see how we get the output. So O equal to W into input, weight into input. That's what I'm doing here. W equal to weight into input. Input is nothing but the ABC values. We are getting the O value. So after getting the O value, so what we have to do? After getting the O value, what we have to do? So here X is nothing but your desired output. Don't confuse. X is nothing but the desired output. O is nothing but your model prediction. O is nothing but the model prediction. Once you got the O value, next you have to calculate the change in weights. So delta W equal to eta into desired output value, nothing but your X column, minus O value that you calculated here, multiplied by your inputs A, B, C. Your inputs of the current sample A, B, C you have taken. You are getting the delta W. So after that, what you have to do is, after calculating the delta W, you have to update W equal to W plus delta W. W equal to W plus delta W. So once you getting the delta W, updating the W values, what you have to do? We are passing only first sample. Now we are going to update your sample count. Sample equal to sample plus 1. Now check whether we cover all the samples, whether we cover all the samples in a training data or not. Whether you cover all the samples in a training data or not, we have to check. So that means you have to check whether your current sample is greater than n. N is nothing but the number of samples in your training data. If it is yes, go to next step. If it is no means all the samples in a training data is not covered. Only first sample is completed. Now sample number becomes 2, but in our training data contains 10 samples. All samples are not covered. Then what we are do with the second sample? Again calculate the output and again calculate the delta W, again calculate the, again update the weights and again go to the next sample. This process will be repeated, right? Now if all the samples are covered, yes, all the samples are covered, then what you have to do? You have to update our iteration value. So iter equal to iter plus 1. We have to update our iteration value. Iter equal to iter plus 1. Now what we have to do? Check whether all the iterations, maximum number of iterations reached or not, because in the initialization we mentioned epochs. That's nothing but the maximum number of iterations. So what we have to do here? So iter should be greater than epochs. Iter should be greater than epochs. If it is true, that means you are reaching the maximum number of epochs. It is a true S. Then you need to store your model, ANN model, and deploy the model for your real-time prediction. If you are happy with the errors, store ANN model and calculate errors. And if you and your clients are happy with the errors, then you deploy the model. So later you can stop it. If it is not, it is no, that means your current iteration is not reaches the maximum number of epochs you mentioned at the time of initialization. Then what we have to do? Again, go back to your first sample, again do the same process. So this is the your complete flow chart for the withdrawal of learning. This is the complete flow chart for the withdrawal of learning. Withdrawal of learning process to train the neural network model, to train neural network model. This is how the model will be trained. Train the neural network model is nothing but the update the weights. This is how we are updating the weights. You can see here, we are updating the weights here. This is how we are updating the weight during the training process. We are updating the weights in such a way that your error will be minimum. You are going to predict the output very close to your actual output. You are going to predict the output O very close to your desired output, that is called as the D. Very close to your desired output, that is called as the D. Okay. Fine. So this is the complete flow chart, right? Now I am trying to coding it. We are trying to coding it, right? So now come to the coding part again. So already we read the data and we split the data for the training and testing. So what the next step? Randomly initialize the weights. So this is the random weight initialization. I want to randomly initialize the weights between the -10 to +10. And what is the shape of your weight matrix? 3 rows and 1 column. Why it's the 3 rows and 1 columns? You can see here your model W11, W21, and W31. 3 rows and 1 column. Why only 3? Because your model, you can see 3 input neurons and an output neuron. So 3 rows and 1 column. 3, 2. Only 3 values you have. Only 3 values you have. W11, W21, and W31. That's it. Right? Are you able to understand, right? Fine. Okay. Fine. So next one is, so now, okay, weights initialization is completed. So these are the initial random weights. Now, learning rate value, how much? So you have to initialize the learning rate. You can see this flow chart. You have to initialize the learning rate eta. So I am initializing the learning rate very small value 0. This is eta value. L means eta value. Learning rate value 0.001. 0.001. This is the learning rate. This is my learning rate eta. Learning rate eta. This is my learning rate eta. Okay. Okay. Now you can see I am using the two for loops. Why? You can see here letter rate loop. Two loops are there in your flowchart. You have the two loops. Inner loop is for the sample. Inner loop is for the sample and outer loop is for the iteration. Inner loop is for the sample, outer loop is for the iteration. So you can see outer loop. So you can write epochs equal to 100. So 100 epochs I want to run. So you can call here epochs. You can call here epochs. So that means outer loop is for the 100 iterations. Outer loop for the 100 iterations. And whatever the inner loop is for the samples in the data set, training data. So number of samples in a training data is coming from number of samples in a training data. So number of samples in a training data, that's nothing but the Q1. So number of samples in a training data is nothing but the Q1, right? That's why your outer loop, your inner loop for J, that is called sample in range of Q1. In range of Q1. Why Q1? Because Q1 represents the number of samples in a training data. Okay. So what's the next step? We are trying to calculate the O. O is nothing but the matrix multiplication of weights and the inputs. Weights and the inputs, right? So O equal to NP dot. That means matrix multiplication. Between which matrix? One matrix is the weights, W, and another matrix is the input feature. Input feature of particular sample, not all the features. Only for the particular sample. If it is the first sample, then you have to consider, if it is the first sample, you have to consider only these three. If it is the second sample, you have to consider these three. If it is a, third sample, you have to consider these three. If it is the last sample, you have to consider these three. So only first three parameters you have to take as input, because last one is the output. Desired output, D value, nothing but X. Okay. So now, so output equal to matrix multiplication, NP dot, that is called matrix multiplication of your weights and data trained in the training data of a corresponding sample. You take 0th column, 1 column, 2 column, 3 is excluded. In Python, whatever the endpoint is there, that is excluded. So 0, 1, 2. So that means 0th column is 1 column, 1 index means 2 column, 2 index means 3 column in Python. The people who are good in Python are able to understand. So first 3 columns only you have to consider. You have to consider only first 3 columns. So this one and this one and this one, 0.1, 0.2, 0.3 only you have to consider. So those input values should be multiplied by your weights, then you will get the output value. O is the O equal to your input into weights. That will give the predicted output by your neural network model. Okay. So after getting the predicted output, from here, now what next step? Delta W. How we got the delta W? So delta W equal to eta into D minus O into this ABC. That are the input features. Eta into D minus O into ABC. That is the input features. Okay. Delta W equal to DW. Delta W equal to eta, nothing but learning rate. What is the learning rate? L. Learning rate multiplied by D. D means desired output. Where you get the desired output, you can see our data. Desired output is nothing but the last column. This is my desired output from the data set. So this last column I require. Last column means this is the 0th index, index 1, index 2, index 3 column. So you can see here from the data train, for the corresponding sample J, on which sample we are working, you have to take the data output only. And third column, if suppose J equal to 0, J equal to 0 means 0 sample. 0 sample means this row you have to take. In this row, third index 2.3 you have to cancel here. This is what I am doing. Third index 2.3 come here. Whereas O is nothing but the predicted output. Eta into this is the D minus O. Eta into D minus O into eta into D minus O into ABC. But that will be column matrix. So for that purpose, what I'm doing, multiplied by data train, that's the training data of a particular sample. Take the first three columns. Take the first three columns. Take these first three columns and make it transpose. Make it transpose because you can see A, B, C. Make it transpose. It is a row matrix actually, and you have to make it transpose. I'm in the column I required. The transpose dot T, nothing but the transpose. Then you have the delta W, DW. Once you got the delta W, then we are going to update the weights. So W equal to weights plus delta W. And finally, you can print weights and the shapes. So this is the your withdraw of learning method to train your neural network model. This is the withdraw of learning method to train your neural network model. To train your neural network model. Okay. Now I want to train this model for the 100 epochs. It's executing. That's fine. So execution is completed. Training was completed. And finally, I am getting the weights. So actually, initial weights are 0.08 minus 0.08 minus 6.91. And my final weights are 1.83, 2.185, and minus 5 something I am getting. Right? So this is my final weights. So now I am trying to store my model. Store my model means, so you have to store your W11 final W11 value, final W21 value, and final W31 value. Final W31 value. I am getting these weights. That's how our training was completed. Now what we have to do, how we know whether our model is predicting properly or not, whether our model is performing well or not, that is based on the errors. So we have to calculate the training errors and also testing errors. How we calculate the errors? First, we have to calculate the predictions. Already weights are updated. These are my updated weights. Already my weights are updated. These are my updated weights. Okay. And based on these updated weights, you can give all the training inputs and calculate the predicted output, and the predicted output compare with your training outputs and calculate the error. Similarly, give the testing inputs, calculate the output based on the testing inputs, and those outputs, predicted outputs should be compared with your testing output, actual testing output that is available in the testing data, and calculate the error. So that means what I want to tell you here is already model is ready. Already I have the model is ready with some W11 value 1.8 and W21 value and 2.2 and W31 value -5. Let us do. Already model is ready with these trained these weights. Now you have to give the training data, all the training data, and calculate the what your model is predicting. And this model prediction is compared with your actual output X and calculate the error. That's the training error. Similarly, give the test data and calculate the test output. Predict that, find the predicted test output and compare with your actual output available in the testing data. Calculate the error. If these errors are less, then you can deploy your model. Otherwise, you need to retrain the model by changing some various parameters. Retrain the model by changing the various parameters. Okay. One minute. Okay. Fine. I hope you understand, right? So that means if you want to calculate the error, whether it is a training error or it will be a testing error, so you have to calculate the what will be the predictions, what will be the desired output, and what is the predicted output on the training data, and also calculate the desired output and predicted output on the testing data, and calculate the error, calculate the difference. So if you want to calculate the error, you must calculate the predictions. You must calculate the predictions on the training data and the testing data. Right? So that's what I'm doing here. With updated weights, prediction with the testing data. So you can see here, thread underscore test is a variable. I am creating a array with all zeros. Q2 nothing but I want to find the error for the testing data. So number of samples in the testing data, that is the Q2. So how many number of samples are available in the testing data? Those number of elements are required in a matrix. Those elements will be updated based on the predicted value. That's what I'm doing here. So what I convey here is np dot zeros q2 nothing but np dot zeros of q2 comma 1 is nothing but create a array with q2 rows. Q2 rows. That is based on the number of samples in the testing data. In our case, we have the only one sample. One row and one column, one row and one column with zeros. With zeros, you have to create an array. Later, we will update this array with a prediction. Later, we will update this array with a prediction. You can see here. Now, for J, nothing but the sample in Q2. Q2, nothing but the total samples in testing data. You can take down sample. And that data, you have to take data underscore test. You have to take that sample, multiply with weights. How we get the output? Output y equal to w into x, right? So w is nothing but the weights. X is nothing but the, for the testing data, take the corresponding sample for the first three columns. First three columns are the your inputs. Last column is your output. So first three columns, nothing but the, your inputs you have to take and multiply with weights. And multiply with weights. And whatever the n2 value you are getting, so those n2 value is stored by print underscore test here. You have to store. Initially it is 0. Later we are going to update with this predicted output. Now predicted output will have the your prediction. Predicted output will have the prediction. So I am getting the some value like this. Similarly, training data also. Only change is here I am taking the Q2, here I am taking the Q1. Why? Q2 represents the number of samples in a test data. Q1 represents the number of samples in a train data. Here print underscore test is a variable to store the predictions on a test data. Here print underscore train is a variable to store the predictions on the training data. And for J, each sample in your training data you have to take and do the matrix x into input into weights. You will get the output and that output value is stored in this spread underscore train. So you will get the different weights. You will get the different weights. Okay. Now, if you want to calculate the error, you have to calculate the error. How we calculate the error? If you want to calculate the mean square error, in a Python, you have the sklearn.metrics. From sklearn.metrics, import mean squared error function or method. Import mean squared error method or function from this sklearn.metrics. And if you import that mean squared error, now you have to pass your prediction and actual. What is the prediction available in the pred underscore train? Training predictions, pred underscore train, and actual data underscore train. You have to give the actual value and also prediction value. Then it will give the training mean square error. Similarly, if you want to calculate the test mean square error, give the testing prediction and also give the predictions in the test data. This is the actual data, this is the predicted data. This is the actual data, this is the predicted data. This is the training data and this is your testing data. Then you will get the training error and testing error. So you can see here. So these are the errors I have. So my errors are very large. This is 18 and this is the 21. If these errors are good, then you can stop the stop your training process. You can directly deploy it. You can directly deploy your model. So deploying a model is nothing but the use the updated weights in your application. Deploy a neural network model in the backend of application is nothing but the use your updated weights in the backend. Use your updated weights in the backend. Okay, use your updated weights in the backend. Okay, it's clear, right? Use your updated weights in the backend. Okay, so let's assume, suppose if you are not happy with the training and mean square error and testing mean square error, you feel that it is a very larger value, then you can retrain it. Again, go to random initialization of the weights and again train it, and again do the predictions on the testing data, again do the predictions on the training data, again calculate the training error. Now I'm getting the 10 and 17. Still you are not happy, let us assume. Then again do it something. So again maybe you can change this learning rate. Again initialize the random initialization of your weights and again train your model and again do the predictions on testing data, again do the predictions on the training data and again do the calculations. Now you can see that my error is 0.72 and 0.46 almost equal to 0. I'm very happy. Still, if you are not happy, again retrain it. Again retrain this model, again random initialize your weights. And this time you can still increase your learning rate. And again do the predictions, testing data, again do the predictions on the training data, and again calculate the error. Now your error is somewhat lesser, 0.06. So let's assume previously our errors are 10 and 18. Now 0.06, 0.7. I'm happy. Then you go for the deployment. So deployment is nothing but the simply use the updated weights. Deploying any ANN model in an application is nothing but the simply use the updated weights. How? I'm creating an input vector which contains only zeros initially. Later, I will ask the user to enter the value of A, enter the value of B, enter the value of C. Because we have the three variables, right? So you have to enter the three input variables, X, A value, B value, C value you have to enter. And all the values will be stored in this variable input vector. Now that input vector is multiplied with weights that will give your prediction. That will be the prediction. That's how we will deploy. So deploying of a neural network model is nothing but you have to use the updated weights directly. Use the updated weights directly. Okay. Simply run this one. You can give some values, any values you can give. Otherwise, you can take the data from here only. Maybe I want to use 0.1, 0.1, and 0.3. I want to give the first input 0.1, next input 0.2, next input 0.3. Now it will give the predicted output is 2.3. My predicted output is 2.3. You can see the data. The data also my predicted output is 2.3. That's how your model is already trained. So once you give the inputs, it is able to predict what will be the corresponding output value. So my model is predicting 2.3. Now actual value is also 2.3. If you change something else, like can we try 0.4, 0.5, and 0.2? 0.4, 0.5, 0.2. So you can run again. You can consider 0.4, 0.5, and 0.2. So I'm getting the 4.3. See the output here? 0.4, 0.5, 0. Output is 4.3. And here also we are getting the 4.3 output. Why you are getting the same value? Because your model is already trained. It is able to predict whether you are giving, if you are giving the input values, it is able to predict what will be the corresponding output. Initially, we don't know how the A looks like. But once our neurons are trained, if you give this is a slant line, this is a down slant line, if it's a cross line, then you can recognize this is the A. Like that, if you are giving the inputs, then it is able to predict what will be the output. What will be the output that's given here. So this is how we are use the withdraw of learning to train the neural network model. Basic. Okay. So till now we discussed about the algorithm, withdraw of learning algorithm, its implementation in the Python. Now we will take a break of 15 minutes and join by 3:20. Join by 3:20. Later we will increase the complexity of the model further. Now we will increase the complexity of the model further. Okay. So take a break and join back by 3:20.